Good morning, everyone. We'll be starting our webinar shortly. As we wait for others to join, please note that all lines are muted except for the presenter. We will be hosting a question and answer session at the end of the presentation, so if you have a question, please use the questions feature on your computer screen. If you are not joining us on your computer, you can contact our presenter directly with the information provided in the webinar. I'm pleased to introduce Mark Roth. He has almost 20 years of experience in the industrial maintenance solutions industry, developing new products, field testing prototypes, and training personnel on preventative maintenance. With that, I will turn it over to Mark.
Hi, everyone. I'm Mark Roth, and I'm sitting here actually with Ray Field, who is our director of our Chemical Solutions division. So the two of us will kind of go through some of the basics of boilers with you. As Courtney had mentioned, we're going to have a Q&A at the end of it. So if you have any questions, you can type them in, and I'll get to as many as I can. I just wanted to go through some of the things that we'll be talking about today. I just wanted to talk some of the basics about these larger industrial boilers is what we're talking about, like water tubes and Firetube boilers, why it is that we need to clean them, how we do some of the maintenance and some of the solutions that we offer, the differences between chemical cleanings and mechanical cleanings, and some of the specifics about each of them too, because we can go into a little bit more detail about it. But I will jump in now. I hope to keep everybody awake. Let's get started here. So the kind of the basics. Again, the type of boilers that we're talking about, we'll break down into two categories. Firetube boilers, which Cleaver Brooks is one of the bigger ones, and it's depicted in some of the pictures here. And basically, it's fuel running through the tubes in the boiler. That's where the burning is taking place, and the fuel oil that's being burned leaves behind a deposit. Sometimes it's fuel oil, sometimes it's bunker oil. Some places like greenhouses might burn wood, and each type of fuel leaves behind a different type of deposit. And those deposits will insulate the tube and hurt the efficiency of your boiler. And that's talking about fire tubes. On the other side, you've got water tube boilers, which run water through the tube and is heated from the outside. And which can get inside those tubes are mineral deposits that build up over time. And again, what it ends up doing is insulating the tubes and hurting the efficiency of the entire system. So you've got two different types. One that's what we would call a dry cleaning, which is a fire tube, where you're cleaning soot out of a tube. And one that would be more of what's considered a wet cleaning, where you're cleaning mineral deposits, slime, algae, mud, that sort of stuff out of the inside of a water tube boiler. So why are we cleaning boilers again? The efficiency and how much fuel you're burning is tied directly to the heat transfer of the vessel. The more buildup that you have on either the inside of the tubes or the outside of the tubes is going to affect that heat transfer. And the more insulation that you have, the more fuel it's going to take to achieve the same benefits that you're looking for to get that heat. And it's going to cost you more money. It's going to take more time, and it's going to limit the lifespan of your machine. If you don't take care of these on a regular basis, they will not last very long. I'm going to go into some of our calculators that we have on our website. So we have an interesting page in our resources portion of our website that allows you to calculate how much money you might save in fuel costs by cleaning boilers, or if you needed to figure out how much descaling chemical you might need, it'll figure that out for you as well. Ray, are you a little bit more familiar with the calculators? Have you used these often, or?
I've written actually the algorithm for the water side. We're talking about scale versus horsepower versus hours of boiler operation, that type of thing. Do we have a calculator for the soot on the fire side, or is it just relative to mineral deposition on?
Yeah, it's just I think it's just taking into account how much buildup you have inside the tube.
Okay.
So it could be water or fire safe.
Yeah, I mean, it's to Mark's point. And we'll discuss a water tube boiler first. On the inside of those tubes, the boiler is a great source of evaporation. It's throwing a lot of steam. You get mineral fallout that's happening on the inside of the tubes. That acts as a great heat transfer insulation type of effect that ends up happening. And so the efficiency of the boiler is reduced. And really, I mean, you're kind of subtly, or more than subtly, decreasing the efficiency of the boiler, because literally what happens in a water tube boiler, in the context of a water tube boiler, is the heat on the fire side can't get through that heat flux can't get through the calcium layer that ends up on the inside of the tube, so to heat the water up. So you have to burn more fuel to get a pound of steam than you would if you had a clean tube. So these calculators go to basically the input parameters, where you just put in your horsepower. You're going to look at the hours your boiler is operating annually, what type of fuel you're combusting, and then basically a characterization of the type of deposit. You know, what is it? Is it calcium? Is it iron? Is it iron silica-based deposit? And what is the thickness relative? And that's kind of quantified in more subjective terms, light, medium, heavy. And then what's interesting about this is that you will see appreciable savings when the tubes are clean and allowed really to do their job, and the heat flux across the tube is optimized. And really, even with good chemical water treatment programs, you end up at the end of the year, when you end up taking the boilers down and looking at that, there are calcium layers that are stereotypically in the tubes, even when they're treated well. Now, conversely, on a fire tube boiler, you get the same type of effect, but in the water jacket, you're having the fallout of minerals from the outside of the tubes, and the fire is in the tubes, hence a fire tube boiler. So your heat is coming from the inside of those tubes into the water jacket, where you're producing steam, and then you end up actually there's two problems occurring there. Not only do you have the carbon buildup that's happening on the fuel side through the tubes, but you have deposition of calcium that's happening on the external side of the tube. So you're creating an insulation barrier on both sides. So it's always a good practice with a fire tube boiler to descale or the water side, or get a vacuum setback on the fire side of the fire tubes.
So we'll talk a little bit about the different types of maintenance that you were talking about there. It's one would be cleaning, or kind of a mechanical cleaning, which would be for cleaning the insides of tubes, and descaling, which generally we're talking about the outside of the tubes on a fire tube boiler. So again, boilers are cleaned on usually an annual basis. I mean, if you see a performance difference, and you can jump in there more frequently, but usually you're looking to get in there at least once a year and clean out the tubes. And if it's a fire tube boiler, you probably want to go up top, open the manhole, and take a peek inside and see what the outsides of those tubes look like. It's a pretty tricky job to treat water that's in a boiler. That constant temperature change and from one extreme to the other really tends to pull the minerals out of the water and coat the outside of the tubes. And not everybody kind of gets that treatment quite right, so that they can keep the outside of the tubes good too. And a lot of times that gets neglected, and you might have nice clean boiler tube, but on the outside it's still scaled up and still hurting your efficiency. So when we're talking about mechanical cleanings, well, the oldest style would be just rods and brushes, where you've seen guys that have a 20-foot rod and stick a brush or some kind of scraper on the end of it and just scrape through the tubes in the boiler to try and clean it up. And not a really efficient way of doing it. You're pushing a lot of soot all over the place, and it's exhausting. So it's not too many places are still doing that, but once in a while I've been in a bunch of mechanical rooms and still see rods laying around that they use as a backup here and there. Some places will use compressed air. Again, that can help you somewhat, but generally it's not going to get scale off the walls. It'll get whatever is kind of loose and already ready to come down, but it's not going to kind of scrape the scale or scrape the soot off of the walls of a tube. So it's not a really efficient method of doing it. And then you have motor-driven rotary brush machines. So those are your mechanical cleaners. That's kind of what our company was founded on, is sort of a big automatic tool. Kind of looks like a gun that you would put up to the tube sheet. And inside this gun, there's a steel tape, a giant steel tape, 26 feet long. That it's kind of like a giant tape measure. And you flip a toggle switch on the machine, and that steel tape is going to push a brush or a scraper down the tube at 3 feet a second. And at the same time, it's hooked up to a high flow soot vacuum. And it's important to make sure that you have the right type of vacuum too. It's not the place for a Home Depot shop vac. One, because the filtration on those isn't really meant for soot, for going down to 10 microns and filtering that soot so that it's not blowing back into the air or hurting the carbon brushes in your motor and causing the vacuum to fail. And two, because you're talking about picking up light materials over really long distances. You know, a large Firetube boiler might be 20 or 25 feet long. And what you need right there is a vacuum that has a high CFM or moves a significant amount of air. So CFM is cubic feet per minute. And what you're looking for is 200 or more cubic feet per minute of air that the vacuum can suck, so that you know it's getting all of those light particulates that are 20 feet away or 25 feet away. Now on the chemical side of things, again, we talked about taking a peek in the manhole of the boiler and seeing if what shape the outsides of the tubes are in. And a lot of times you're going to look in there and you can see right off the bat that there's a considerable amount of scale. And what you would use then is a descaler. So it's a type of acid. Most of the time you're going to use a user-friendly type. We make a product called ScaleBreak. And the idea is that it's not going to attack the metals around it, but it is going to attack that calcium and start to dissolve it and put it into the water stream. And the way that you do this is not just by pouring it in and letting it sit there, is that it actually has to circulate in order for it to work properly. And we'll talk just a little bit more about that in a minute. So we've got different amounts of fouling. So sometimes in a boiler, if you're burning a heavy fuel like number 6 oil or bunker oil or something like that, it's going to leave behind a pretty heavy deposit. Sometimes you're burning something that's a little bit cleaner, like number 2 oil or natural gas, and that doesn't leave quite as much soot behind, but then it also depends on how your boiler's tuned and if it's getting the right airflow as well. So a finely tuned boiler is going to leave even less deposit behind, but a boiler that's burning a heavy oil is generally always going to leave behind a thick deposit of soot. And there are different tools that you would use in those cases. So you can see the pictures here. These are some rotary tools that are used with a machine that spins a brush or spins a scraping tool on the inside of the tube as you run it down through the boiler tubes. What you have in the first picture is a spring-filled brush. So each of those bristles are tightly wound little springs, and they scrape the inside of the tube and get all that soot off. And sometimes I've been to waste facilities where they might have really heavy deposits and a brush is not strong enough to get them off the walls. And what you would resort to there is what we call a flex hub tool. And those 3 arms are kind of like blades, and it's centrifugally activated. So as the machine starts spinning, the blades flare out to the inside diameter of the tube and give it a good scraping, gets everything off of there. We've even had some where we'll mount a drill bit on the front of that flex hub tool so that you can drill forward at the same time that the blades are scraping the walls. So thick fouling, that number 6 dirty oil that we're talking about, is usually something where you would want to use a rotary machine for doing your mechanical cleaning, and a light fouling where we're talking about number 2 oil or natural gas, or sometimes when places are burning wood, you could go with our Soot-O-Matic, the one that I was describing before, which is a kind of a straight punch, an automatic feed tube cleaner that handles a lighter soot deposit. I'm going to show you a quick video now of the rotary machine. So this is the Ram 4X package. And what we'll see here is a guy cleaning a big Firetube boiler using a rotary machine connected to that high flow soot vacuum that I was talking about. Now these brushes come in all different sizes. Generally, boiler tubes are sized by the OD of the tube, and they go from 1 3/8 to 4 inches. The most typical size would probably be 2.5-inch OD. And you can see it's a pretty simple process. You wheel the vacuum up to the boiler. You got your tube cleaner there, which you're going to actually lay down on the handlebars. It's a regular 110 electric, 220 is available. You get a nozzle that, again, is sized specifically to the type of the size tube that you're cleaning, which, again, could be 1 3/8, 1 5/8, 2 inches, 2.5, 3, 3.5, or 4 inches. Once you've got your flexible shaft on, you can put your tool on it, and you're going to run it through that T that's going to connect both the high flow soot vacuum and the rotary tube cleaning machine, and allow you to suck the soot out from the same side of the boiler that you're cleaning from. So in this case, he's using one of those spring-filled brushes that I was talking about. So right here, he's stepping on the foot pedal, and what that's doing is activating the core of that shaft to start spinning at 862.5 RPM, which we consider is kind of like that sweet spot, that right speed for not being too aggressive, but for being enough so that you can clean the inside of the tubes. You push the cable down the tube, which it kind of, once the brush is spinning, it kind of helps itself along. It's not a very labor intensive. And once you get to the end of the tube, you pull it back out and move on to the next one. And again, the rotary equipment is what we'd usually use for somebody that's cleaning a heavier deposit. This is going to be your most thorough method of doing a mechanical cleaning of the inside of a tube. Now, that machine was electric. What we've also got are air-powered machines, and they can be used for either wet or dry applications. One of the reasons that we made the smaller AWT 100, that one that's on the left, is it's small enough that you can actually climb into a water tube boiler drum with it and have it next to you so you can clean. So water tube boilers are not set up quite as easy to get to as fire tubes are. So sometimes you've got to climb into it, and you're in a kind of confined area where you're feeding the cable down, and having a machine 20 feet away from you is not the ideal way to do it. So you can actually bring this machine right into the boiler with you. You connect the air hose to it and a water hose, and you're good to go. And air-powered machines are particularly powerful. They that AWT 100X, if you're giving it enough air, it's the equivalent of having like a 3-horsepower machine that's pushing it. You can put pretty much any size tool or on the end of the cable, and you can run this machine wet or dry. So as he's going down the tube, if it was a water tube boiler, you would have water being injected out through the jacket of the flexible shaft. So it's kind of giving the scale that you're scraping off somewhere to go as you're cleaning it. Or if you were cleaning a fire tube boiler where you do not want to add water to the cleaning mixture, you would just use it dry, and you would go down the tubes and have the soot vacuum pulling the soot out for you at the same time. And I've had guys that are newer to boilers and say, well, why don't you just, hose down the boiler to get the soot out? And that's just not an ideal way to do it. First, mixing water and the ash from the boiler is creating sulfuric acid, which is not good, and can damage the tubes over time. And in some states, it's actually, they have regulations against using water in those tubes. But it's just not a general rule of thumb is you just don't want to inject water into a fire tube boiler. I think we've got a video now of the Sotomatic. So this is the machine that's we were founded on. That's kind of like a straight punch. So this would be if you're cleaning a boiler that's not too fouled, somebody that's burning number 2 oil or natural gas. And this is kind of the fastest way of doing it. Oh, what we're looking at here, and let me pause it for a sec. So we did a test in a boiler room in New York where the gentleman on the left, on the far side in the video, is using the Sotomatic, which is that auto feed gun. And the person closer to us is using a rod and brush setup, where he's just got a brush on a steel rod, where he's going to just push that down the tube in hopes of scraping as much of the soot off as he can, whereas the other guy is going to be using the auto feed machine. So just to give you an idea of how quick it is as opposed to doing it manually. Oh, I'm sorry. I'm going to go back one. They're at their marks. Get set. And go. And go. So it's, first of all, it's not easy pushing a brush down the tube. So you can see on the side of that Sotomatic there is a red distance indicator that's spinning as the brush goes down the tube. So he can see exactly how many feet out he's pushed the brush while he's using it. And he has a little mark on it so that he knows when he gets to the end of the tube, he can stop it, put it in reverse, pull and wait for the brush to come back in and move on to the next tube. Don't forget, at the same time, he's also vacuuming the tubes out. So he's able to do 3 tubes with the Sotomatic in the time that it takes Andy to do 1 tube doing a manual rod and brush method. Now we're going to talk a little bit about the water side of the boilers, where you would get that scale buildup that we were talking about. Ray, I'll let you jump in with why scale even builds up on the outside of these tubes. It's a good picture.
Sure. We'll take a Firetube boiler as an example. And I'll liken this to a tea kettle effect. So when you have water in the tea kettle, you've got the burner underneath it, and you're evaporating off the water, and only pure water will evaporate. It leaves behind all of the dissolved solids or the minerals that are in the water, and they end up plating out. Now, that is basically a good analogy to what's really happening in a Firetube boiler. A Firetube boiler is taking makeup water that has a large mineral content, and the boiler is cycling or concentrating those mineral solids as the evaporation, if you will, process, or the steam is being generated and going out of the boiler. All of the minerals that came into the boiler are remaining behind, and these minerals, unfortunately, it's not like putting sugar into water, where the more sugar you put into it, the more dissolvable it is. In this case, this wants to fall out and leave a very adherent, tenacious scale on the inside of the boiler. Not only with that, as you can see in the picture, you see a lot of brownish orange looking material. Those are corrosion byproducts that are happening in the boiler, because you have oxygen intrusion that's in the water that's coming in. You have a lot of heat and the oxygen can cause pitting effects in the boiler itself. So the boiler is kind of being punished over time, and there are pre-treatment devices that you can use, like a water softener, so that's going to strip out the minerals that would otherwise end up baking out on the inside. But a lot of times you don't have a water softener bank. The other thing that can happen is that the export steam, or the steam coming out of the boiler, goes from the vapor stage and recondenses back to pure water and is brought back to the water. Now, the more you can bring back, the better. But a lot of times the export steam going out doesn't come back. So you're coming in with straight makeup water, and you're concentrating those solids, and you're ending up with these very, very thick scale layers. Also, there's a big problem that we've seen is that it's kind of out of sight, out of mind. A lot of times the manhole covers are not really open, or a glance may happen and say, okay, well, it looks kind of all right, and the manhole cover is put back on until an inspector gets there and then looks at it and says the boiler is unacceptable. We can't basically check off on this boiler for its operation until it's cleaned on the water side. I've seen boilers where there's so much scale that the tubes actually come, there's a term called bridged, where it looks like you literally have backed up a cement truck and poured cement in. You can't even see the differences in the tubes. And when it's really just counterproductive to run a boiler like that, because there's no heat. There's no heat transfer anymore. You can actually even melt the boiler tubes because of the water steam mixture on the water jacket side is actually acting as a coolant, paradoxically. So it's a good practice to use a biodegradable descaler, such as our ScaleBreak product.
Let me jump into that. Let's talk a little bit about the descalers and the different types. Earlier I mentioned that what we would use for doing it is kind of a user-friendly acid. What are we talking about with user-friendly acid?
Yeah, well, these are biodegradable descalers. They go in, they're going to strip away the insulation layers in boilers, and at the same time they're formulated with heavy corrosion inhibitory packages. So they're acidic, but they're biodegradable, and they're buffering agents that are in there that are good from a environmental health and safety standpoint. But it'll do the job. It'll go in and get rid of the scale and corrosion byproducts and tuberculated iron and everything else that's residing inside the boiler, while also being very safe from an environmental health and safety standpoint.
Okay. And let's take a quick look at a video of how some of the descaler works and how it reacts to calcium when it comes in contact with it. So we're looking at looks like a heat exchanger that we submerged into a tank. That's pretty badly scaled up. That was a quick view of it, but yeah, as soon as the calcium comes in contact with the descaling chemical, it starts to react and starts to dissolve. And we talked a little bit about the importance of movement while this is happening too. So if you're looking to descale a boiler, you need to have water flowing constantly. It doesn't have to be at a high pressure, but you have to have enough flow so that it's moving. Why is it important for it to continue to be moving the descaling the acid when you're cleaning a boiler or heat exchanger?
You know, typically you want a good flow velocity. That's not to say that you can't do this statically. I've seen it done statically, where you fill the water side up with a descaler, and it does the job. But when you have flow velocity coming over the tubes, that just enhances the descaling performance. So it's always good to have that. I think really what it's a function of is you have more force that's being applied, and you have turbulent flow commingled with the descalers happening at the same time to give you the best cleaning performance.
Yeah. So there are different types of descalers or circulating machines that we use for doing it. There are different sizes according to the amount of the volume of water that you need to be moving. I don't have pictures of all of them on this slideshow, but the GDS C40 that's mentioned there is the smallest one, and that would be used for cleaning smaller vessels. Sometimes in a boiler room, you'll also come across a smaller heat exchanger that's responsible for what they would call instantaneous hot water, where water and steam are being injected into a small heat exchanger and creating scale also. And again, you want to descale it by using one of these user-friendly acids and having a descaling machine that can do it. And the way that pretty much all of these machines came about was we were listening to guys in the field that were doing descaling already, and we'd ask them, okay, so you've got an acid that you're running through and it's doing a good job, but how are you circulating it? And for the most part, everybody had the same answer was, well, we got this submersible pump and we throw it into a drum, like a plastic drum, and we cut some holes in it and we rig up some hoses and we get it going, and it does the job except for, next week when we have to go out and do it again, somebody has to rebuild the pump or buy a new pump because it's shot from being sitting in the acid for so long, and it's just generally just not a really safe or efficient way of descaling. Walking into somebody's mechanical room with a bucket full of acid splashing around and trying to use that as your maintenance tool. So we developed machines that are self-contained, that are very user-friendly and roll right up and start doing the cleaning. The picture right there is of our GDS 100, which is a machine that's used for doing a boiler because it handles a much higher volume of water. This one is putting out 95 GPM, so it's the right amount of flow and head pressure so that it can handle a large vessel like a boiler. And we can show you some more of that, or if you have any interest in what would be the particular type or size machine that you'd need for doing a specific job, you can always call in and speak to one of the sales engineers here, so we could kind of walk you through what the appropriate machine for your application would be. Our next slide is, again, showing the boiler calculator, but this time it's on one that would help you decide or help you figure out how much descaling chemical that you would need to use for a job. So here you're putting in the volume of gallons that are in it, and giving it an idea of how much scale buildup you anticipate, and it's going to tell you how much chemical you're going to need, as well as how long you have to circulate it for. So there are a couple of different calculators in there related to boilers, and I would say just again go to the Goodway website and to our resources section, and there's a whole list of different calculators that can help you figure out everything from how much you're saving in fuel to how much chemical it is that you need to do a cleaning job. Because just buying one 5-gallon pail of descaler and thinking that you're going to go and clean a Firetube boiler is not going to do it for you. You won't be happy with the results. It's not going to do very much, and you'll be going back again to do the job. So bring the appropriate amount with you when you go to do a job. So I talked about our calculators, and if somebody is interested in the descaling chemicals, we put together some free sample kits, so you can actually see what it does, and it comes with the calcium tablet, so you can actually put it in the little cup there, and enough ScaleBreak so that you can do a live test, or if you have some of the scale that you're dealing with, if you want to scrape some off and put it into a little test cup and add some descaler, you can see if your deposit, if what you're dealing with is something that ScaleBreak would work on. So you can just go to the website and request it, or you can, again, call right in, and we'd be happy to send one out to you. And there are different formulas for different types of deposits and different types of metals that you're dealing with, too. So again, my name's Mark Roth, and Ray Fields was with me today, and that's the general number to call into Goodway, and you can reach me directly, or you can just tell them what state you're calling from, and any one of our sales engineers here will be able to help you. So I think I'm going to close this and go over to see if there's any questions. Here we go. I'm not seeing it. There we go. No open questions, okay.
Okay.
All right, well, it's been great talking with you, everybody. If there are any more specific questions, I know some of this is very general. We got one question that's asking how often we would recommend doing it. So generally, if we're talking about a boiler, you're going to want to get in there at least once a year. Different states have different laws about how often boilers need to be tested. And let me go to the next slide. Sorry about that. But I'd say at least once a year. Ray, was the same thing you said for Watertube boilers?
Yeah, I would recommend the same thing for a Watertube or a Firetube boiler. That in the case of a Watertube boiler, like Mark was saying before, you're going to end up with the same type of phenomena. Only if you're burning, well, if you're burning fuel oil, number 6 bunker fuel, you're going to end up with, you can say that it could be sulfur deposits, vanadium, all kind of hard slag materials that can end up in there. And on the water side, again, there's a large amount of heat transfer reduction that's happening by the insulation layers that are happening in there. So, but yeah, the short of it is once a year as a preventative maintenance cycle.
Okay, and we're also getting asked what's the time frame to complete a cleaning, and generally, well, it kind of depends on the area that you're in and where this boiler is being used, but for the most part, a big industrial boiler that's giving heat to your building and hot water is something that's going to be down for the majority of the summer when it's hot, and you usually have a big window then of a few months to get the cleaning done. We run our boiler year-round, so we can run scale chemical while this is in service. No, you can have water treatment chemicals while the boiler's in service, but you wouldn't do the descaling while it's, that's something that needs to be drained after you're done, right, Ray?
That's correct. The ScaleBreak products are they're powerful against going after scale. We don't really recommend them being used over 140 Fahrenheit. So there, the boiler water in, you know, your water steam disengagement space can be a lot hotter than that. So no, we would not recommend that be used online.
Okay. And are there laws for cleaning per state you live in? Yeah, different states will have inspectors come, and they have specific rules that they're following on what needs to be cleaned and what doesn't. But generally, yeah, you know, some states crack down on it a little bit harder than others, and usually want to get your cleaning done before the inspector comes in, before a state inspector comes in. And once they do, if you don't have it clean enough, they're going to tell you to open it back up and clean it again. Is this process compatible with any type of Firetube boiler?
Yes. Depending, we have several formulas, different iterations of our ScaleBreak products, and depending on the metallurgy that you have, we'll have a formula. We haven't seen a boiler that we haven't been able to descale based on the metallurgy. So we're encountering all the common HVAC metallurgies that you'd be, you know, utilizing in that type of application.
Yep, same thing with the mechanical side. There are different configurations of boilers that you'll come across. There's a company called Airco that makes a specific type of boiler, and The tubes in that are have bends in them, and you would use a specific type of tool that we use just for that. But again, generally, any type of boiler that you come across, we've got something for cleaning it. Any type of industrial boiler, I should say. Yep, yeah, with different types. I'm not familiar with this question here, that specific name of boiler manufacturer, but yeah, with different shapes, there are different tools that you would use for cleaning it. Sometimes you want to use a straight punch, and sometimes you're going to use a rotary machine with a specific type of brush or tool that will kind of thread itself down the tube when you're cleaning it, or be able to make those tight bend radiuses if you need to. You do a scale analysis to tell us what type of cleaner descaler would be needed.
That's a great question. That's often what the protocol is. We would take a sample of the scale itself, and then there would be a composition analysis run in a laboratory where we could tell you the breakdown of exactly what the composition of the scale is. Typically, what you're going to see in a boiler is calcium carbonate. That would be the main with encrusted iron. Potentially with some silica, sometimes you see calcium sulfate, but yes, that's a very good question. And then we can check the efficiency of different products on the particular type of scale that you have. So
yeah, so the quick answer would be absolutely. If you wanted to send scaling to us, we could check it here and see what works on it best. Or again, if you just wanted to have a small sample of some of the different types of descaler that we have, we could send that out to you too, and you could just see right then if it's able to react with it and if it does the job. Okay, I think that's all our questions. I appreciate everybody's time. I hope that this was somewhat helpful, and again, I encourage you to go visit our website, look through our different tools and resources and calculators on there, and feel free to call in. We have a room full of experts that are here and can help you out through your specific application.